Hello and welcome to another Unreal Engine 5 video. In this video we'll make a real-time strategy game. I will make a new series. I'll try to complete it and finish it, and this will provide you with a fully functioning real-time strategy game. It will be military style real-time strategy game. So what we will make in this video, let me show you the end result. I will make the main actor or the main player pawn that moves around the map and selects units and move them, and we will implement the selection of the units and moving them around and clearing them when we click away, and selecting single unit or multiple units. Now let's start by making a new project. Okay, I'll start by selecting the third person. Let's name it RTS. Wait for the project to open, and here in the start, first let's make a new folder. Let's call it RTS game, and give it a unique color to be able to recognize it later. Here first let's start by making the main player pawn, which will act as the camera and give you opportunity to select units and moving them around. I will pick the pawn blueprint, call it player. Also we need a game mode. Let's call it RTS, GM underscore RTS. Open the game mode and choose the default pawn to be the player. Let's make it save and compile always, and also go to the project setting and change the default game mode from here, maps and modes, make it the RTS mode, game mode. Also here in the world settings, change the game mode override to game mode RTS. Now for the player, we need first a root component to attach the camera to it. For me, I will use a collision sphere. Make it the root component. This sphere we do not need the collision, so untick the generate overlap, and also make it no collision. Also need a camera and attach to the sphere. Also floating pawn movement to be able to move the pawn around. For the camera, we need to rotate it to the to look at the ground 50 degrees, minus 50 degrees, and start by setting the location of the player. I will make it in the air. Set actor location. I will first we need the actor location. and add the desired height. For me, I will make like maybe 1000 units. Now let's check. When we start, we are above and looking at the ground. Now let's start by let's make a new input. We need to make inputs, so let's make a new folder called input, and here we need a new mapping context. Where the input, we need the context. Let's call it IMC RTS. Also we need input action. Let's call it IA first move or look. Let's call it move forward. Well, actually we do not need it now, but I will use this for move right. I will use these controls for the keyboard, because for the mouse we do not need this input action. Also we need another input action. Let's call it select and make it a bool. Value type should be bool. For the movement we need axis, because for the forward it will be +1, for the backward it will be -1. So we need, for movement we need axis values. Also we need another input. Let's call it set move location. This will be responsible for giving the location to the units that you select to move. Now before we go, let's delete the input mapping for the default one, and delete this. Do not need this. Or we delete everything in the third person character, because we will reuse it as an AI unit. So delete the camera, do not need it, and let's change its name to maybe soldier. It's called soldier. Delete the third person game. Now let's delete the third person game mode. We do not need it anymore. And also let's move this blueprint to our folder, and remember always to do fix up redirectors when you move anything in the when you move or delete anything in the project. Now let's continue. Now we need to set up our input. Let's go to the game mode. We need the player controller. first let's check if it is valid. Later on when we make our own game controller, I mean player controller, we'll change this, but right now we don't need a new player controller. We need enhanced get enhanced input local subsystem, add mapping context. Here let's select our mapping context, the RTS. Also we need to show the mouse cursor and make the game mode the control for the game and UI to be able to select the UI elements later on when we make factory that make units or that spawn units and anything, tanks. So we need to interact with the UI. We need the also player controller, set mouse cursor, set show mouse cursor, make it true. Also set input mode game and UI. Also remember to change this, the lock mode always to lock, and untick this option, because if you leave it on, when you press, the mouse cursor will disappear. Let me show you what I mean. Here the mouse is bound to the viewport. When I press, it doesn't disappear. Now let's go back to our our player. Let's make it move right and left with the mouse movement. Let's make a custom event. Let's call it move. Here the movement is slightly different because when we made the input mode to game and UI, the mouse will not register movement, only when you press the left mouse button. So I will make the move function depend on the tick. It will be some simple function, it won't take any performance. So first we need to check, first need the player controller, and then we need to check the mouse location, get mouse position. This mouse position is the viewport. Also we need the viewport. Get viewport viewport size, break. So we need to check if the mouse cursor is at the sides of the screen to make it move left and right. So we need to check if the current the X location is the horizontal and the Y is the vertical in the 2D in the viewport. So need to check the location if it is equal to the viewport, the X value of the viewport, but we need to make it decrease it a little bit. because the mouse will not reach the edge of the screen, so we need to make it like -5. Let me show what I say. Let's take this mouse position and print string. Now, like you see, this is the value of the mouse position. So here on the left gives you 1, and here on the right gives you 942, and it should be more because you see there is the mouse does not go to the edge completely. And let's see the screen. Okay, I think you understand my point. So here you need to make it check if the current mouse position is at the edge of the screen. So if it's like this, it is equals the value at the extreme right, so we need to make it move to the right. We need to add input, add input vector, we need the forward vector, get actor forward vector multiplied by 1, sorry, right vector, because we are moving to the right. Get actor right vector, change this to float, sorry, float by 1. Now it will move to the right. Let me show you. And when it is to the left, doesn't move because we didn't check the condition. It is to the right, it's moving, but very slowly. Let me change it to above, larger. Sorry, greater or equal. It's greater or equal to the viewport size. It should move to the right. Now it's moving to the right. Now to make it move to the left, we just reverse this. We add another check here. If it is here less than or equal to, also here -1 or 0, leave it to 0. The current position, if it's less than or equal to 0, you will move to the left. Change this to -1. Now go to the left, doesn't move. Let me check again. Okay, yes, I made a mistake. As you saw, the value on the extreme left, it does not go to 0, so it goes to 1. So to be safe, I will make it 2. I will make it 2. If it reaches, now it's going to the left. Now we are going to the left. Here we are going to the right. The point is, the mouse does not go to the edge of the screen. Okay, now we have it moving right and left. Now the same thing we will do to the up and down. Let me just move them forward or away. Now we have to check the Y also for the to move forward or above. Need to check if the current location is greater or equal to the Y minus also 5 to be safe and to make it smooth. Branch here. Let's duplicate this and move this away. Here we just change this right vector to make it forward vector. Get actor forward vector. Here also need to check if it is less or equal to, also make it 2. You know that the lower part of the screen here is equal to 0. Here is the maximum vertical part of the resolution. Now here check branch. Sorry. Let's duplicate this and make it -1. Now, so let's reverse it. We need to reverse the positions. Here and this one, bring it, or you could just flip this, make this -1 and this 1. Now we're moving forward and backward and right and left. Now to recap, let me just explain what I did. And I used the tick function because the mouse will not register movement to the input, will not register input because the game mode is made to UI. So when you press the mouse button and keep pressing it, it will register input. So it is not it won't help us when we play the game. If we want to move the screen right and left, we should not press the mouse button and move the screen. And what we did is compare the mouse position, current mouse position in the screen to the screen size, compare the X and Y values together. We subtracted the minus 5 degrees or 5 units to be safe, because the mouse does not move completely outside the screen, so it will not get to the maximum values of the screen resolution. So here we compare the X values to move it right, and the minimum X value also to move it left. Here up and down the same thing. Let's comment, call it zoom camera, or let's call it zoom camera. Now the sorry, no, move camera, move zoom, will make it later. Move camera. Now let's make the zoom function. First, let's add a input action. We need it to be a float value, so duplicate the move forward and call it zoom let's make sure it is float also. Now let's go to the context here. First, let's add the zoom. Now zoom, we need two inputs, one for the forward and one for the backward. Middle mouse wheel, wheel axis, wheel up here, and here we need wheel down. For the wheel down we need a modifier, the negate modifier. Now let's go back to also let's add triggers, pressed and released. Also here the same, add the triggers, pressed and released. This trigger will trigger the input when you press the button and when you release it. If you just made pressed and deleted the released, it will only give trigger when you press the button. Now let's go back to the our player. Here let's make first input action, we need it, zoom. Here let's save the action value, let's call it zoom axis. And connect the started execution pin, and we need a delay before we make the value go to 0. Sorry. Here we need delay, leave it at 0.2 and get the zoom axis and make it 0. Okay, let's make custom event, let's call it zoom. Now we need to move the camera, the player along the axis of the camera, so we need the camera forward vector. and also need the floating point movement to make input, add input. Let's multiply it by the zoom value. Zoom axis. Let's add it here in the tick function. Sorry, so I know some people will say that this is inefficient, but it is not some complicated math. It will not take a lot of performance from the game, and also I will try to find another way to implement this. Maybe in the future I will I will find another way and make it more efficient. So let's try here. Now we are going forward and backward, zooming up and down. Now let's comment on this. Let's call it zoom. I think that's enough for the first video, and for the next video we'll make the selection and movement of the AI characters and the AI units. We'll just select them, and we also implement the box selection for the units. Thank you for watching. Goodbye.